you can come across various environmental issues that are caused by daily engineering practices all over the world. It can be seen everywhere, even in our own backyard. I mean, you wouldn't have expected construction in Victoria Park, right? Here, the pond in Victoria Park has been drained. Think of all the marine life and vegetation that have been affected. What would you do with all the fish and the reeds? As engineers, it is part of our responsibility to consider these issues and minimize our impact on the environment. Let's take a look.
Cranes are used in construction to lift many heavy building materials, such as concrete and steel. This enables maximum site productivity. However, cranes can actually cause visual pollution. I mean, picture this. You're trying to enjoy the view when you've got many cranes dotted across the horizon. Not a nice view now, is it? Not to mention, the noise caused during crane erection and disassembly, it wouldn't do you any wonders during a nap or if you're in the office trying to finish off a report. Although, we can't eliminate noise pollution entirely. We can implement methods to manage it. For instance, we can schedule crane dismantling to be done during weekdays when most people are at work. We can also notify residents prior to works taking place via letters of notification dropped into their mailboxes. As an engineer, it is a part of our moral obligation to minimise disruption to the environment. As you can see here, crane disassembly requires careful consideration due to disruption to routine pedestrian and traffic activity. Crane disassembly is done in 3 stages. The first stage involves the removal of the crane segments using a large mobile crane. In the second stage, as you can see here, a small mobile crane flips the segment until it is parallel to the road. Then, the segments are lifted onto the back of a truck, and there you have it, crane disassembly.
Noise pollution is not just limited to cranes in construction. In fact, they can be caused by other machinery such as piling rigs. As you can see here on this Bellevue Hill Primary School, there is construction taking place to build a new storage facility. However, before anything else, site remediation processes must be carried out so as to increase the bearing capacity of the soil. One such site remediation process includes continuous flight auger piling. The construction sequence for CFA consists of firstly drilling a full-length auger with a hollow stem. Then concrete is pumped through the hollow stem of auger while auger is extracted and spoil is displaced. Finally, the reinforcement cage is plunged into the fluid concrete. So let's rewind back to the spoil. What do you think happens with this massive pile of dirt? If we don't consider how to dispose of it, it could wash out and spread to nearby waterways, harming aquatic vegetation and creatures. We as engineers have responsibility to think of ways to reuse the spoil in another construction site, prevent it from spreading by erecting fences around the spoil area, or dispose of it at a landfill.
In addition to noise pollution, water pollution is another major issue that engineers need to consider. This stormwater discharge pipe in Breakfast Point is used to discharge stormwater into the ocean. A temporary sedimentation tank can be built on the construction site. Often, the turbidity or the opaqueness of the runoff water must be tested from this tank before it reaches the stormwater pipe. By testing the water, we can prevent any contamination that may affect marine flora and fauna.
One of the ways to prevent water pollution is to design a good drainage system, which can be used in various structures. An example of this is the retaining wall in Collaray. This wall was built to retain soil and prevent the collapse of the excavated face while a residential complex was being built. However, if drainage is not designed accordingly, it may cause problems. The problems caused by poor drainage include lack of traffic safety, erosion, and reduced bearing capacity in the subgrade and the road structures. You'll learn more about this in 4th year. On this particular site, poor drainage would affect the traffic safety as it is built adjacent to a road leading to a residential complex. Fortunately, the drainage design prevents such problems. The design consists of vertical strip drains at regular intervals on the rock face behind the shotcrete, which is visible in the video. There is also a horizontal strip drain placed at the bottom of the retaining wall that connects to a nearby stormwater drainage system.
How many of you know that Sydney Olympic Park used to be a contaminated waste site? That's right. Prior to the Sydney 2000 Olympic Games, the Homebush Bay area was the result of legal and illegal landfilling operations that spanned several decades. Yep, nothing more than a toxic waste dump. In fact, the area was full of demolition rubble, power station ash, industrial hydrocarbons, domestic rubbish, heavy metals, waste oil products, asbestos, and pesticides. All that nasty stuff. Gross, right? Thankfully, the Australian government allocated 137 million for remedial action to clean up polluted areas between 1992 and 2000. A number of management plans were needed to address issues of pollution and the re-establishment of ecosystems. Contaminated soil was removed from less contaminated parts of site and transported to a landfill that was capped and landscaped to make more space for suitable development. Engineers have been monitoring this site every day, ensuring that the workers as well as the public are protected. For example, dust is collected and analyzed while carcinogens and arsenic fibers are monitored. Luckily for us, we didn't have to deal with this pollution.
Let's take a look at another type of retaining wall that can be designed by engineers. What about these gabion cages that can be found in Sydney Olympic Park? These retaining walls are large free-draining cages of rock that are used to stabilise slopes, prevent soil erosion, and divert floodwaters. The system consists of a series of steel wire mesh cages that hold rocks in place. Gabion cages are flexible in that they do not crack, only move slightly, allowing for soil settlement. Since they drain well, you don't need to worry about the water pressures building up behind the wall. Unlike other retaining walls, gabion cages are also more environmentally friendly because there's no ground disturbance involved. They can also be used for a wide variety of commercial or residential applications such as garden beds, feature walls, and seating.
In cases where man-made construction techniques are not feasible, we can implement natural measures to overcome disturbances to the environment. For example, pictured are the mangroves that can be found in Sydney Olympic Park. As part of the remediation process, the Australian government decided to plant mangroves. The purpose of these mangroves are to capture the area, allowing for filtering of the stormwater before it is released to Parramatta River. These mangroves help reduce the turbidity of coastal waters, as the dense root system protects local wetland flora by trapping sediments flowing down rivers and off the land. These mangroves promote biodiversity by providing habitats to estuarine and coastal fish, crustaceans and mollusks. The mangroves also provide coastal protection by preventing erosion caused by waves and water movement.
Like the mangroves, coastal vegetation can also act as a natural protection against erosion or pollution caused by construction activities. The beach grass pictured act as a windbreak by trapping the deposited sand particles and stabilizing the dune system. So why are sand dunes so important? Stable sand dunes are natural barriers that protect the coastline, acting as buffers against storm surge and high waves. Additionally, sand dunes also protect the land from saltwater intrusion, prevent damage to inland structures, and act as a reservoir of sand to replenish the beach at times of erosion. Finally, beaches and dunes are important for its biodiversity, serving as a breeding and roosting grounds for sea turtles and shorebirds. So without coastal vegetation, erosion of the beach may occur, which would lead on to more major issues such as coastal recession.
So guys, the moral of the story is, as engineers, we need to consider many significant issues that may affect the environment directly or indirectly, a few of which you just saw then. Issues such as noise pollution, water pollution, visual pollution, and land erosion are issues that you need to keep in mind in engineering or construction. So, take responsibility for your actions and save the environment by incorporating sustainable controls in your professional engineering career. Thanks, and we hope you enjoyed the ride.